The format will be the same as the first test, about 40 multiple choice questions. And the concepts are going to be found in mastering. So that's the first place I would look back to is your homeworks. Make sure you've been paying attention to those. Check back through the PowerPoints for some clarification on some of those. Your book can provide further clarification. And for those of you that have been using the discussion board, which is a great tool, and I strongly recommend it, I posted a website that has an atmosphere simulation. It's also posted in your PowerPoint. But for those of you that are working through atmospheric circulation, this is a great place to quiz yourself to make sure you understand what's going on with that. Just to go back through some of the main points that you should look at energy delivery to the Earth. So the sun sends radiation. We receive that radiation mostly in the form of visible light, and we can absorb that or reflect that. Recognize that albedo is the percent of light that's reflected, and that dark colors tend to absorb more, light colors reflect more. The more that we absorb, the warmer that we get. And when we then send out energy, we send it out mostly as infrared radiation. We have gases in our atmosphere. So first thing is the energy budget. Second thing is the atmospheric composition. We have nitrogen and oxygen mostly in our atmosphere. We also have some greenhouse gases, a small amount of water vapor, carbon dioxide, and methane. And what they do is they absorb and re-emit that infrared radiation in all directions. And that can effectively warm up the temperature of our lower atmosphere. Be familiar with the structure of our atmosphere, where ozone is, and what gases depleted ozone in our atmosphere. Then you're going to need to take a look at atmospheric circulation. So take a look at that simulation I mentioned. Know your different wind patterns. Recognize that it's convection in our atmosphere that causes air to rise. So you get more radiation in at the equator. Then it's hotter and you evaporate more. That air rises, the rising air cools, the rain falls, and so you get a lot of precipitation at the equator. The air circulates, and then the dry air falls around 30 degrees north and south, and then you get several bands like that in the atmosphere. So make sure you look at that and recognize that. Also, just for clarification, when air is falling, like at 30 degrees north or south, it feels like it's pressing down on us, and then we experience high pressure. When air is rising, like at the equator, it feels like it's lifting up off of us, and then we have low pressure. Hurricanes develop when you get really low pressure. So you get a lot of evaporation, a lot of air rising, and so other air rushes in. Those are the really strong winds during a hurricane. So that low pressure is the center of the cyclone. That rising air is the center of the cyclone. So make sure you're familiar with that and your wind patterns. And that in addition to the air convecting, the Earth is also spinning. And because the Earth spins under it, the air is deflected. In the northern hemisphere, always, air is deflected to the right. In the southern hemisphere, the Coriolis effect deflects air to the left. Okay, so Coriolis deflects air to the right in the northern hemisphere, to the left in the southern hemisphere. Concepts related to the ocean. The first thing that I wanted you guys to look at was the surface ocean currents. So if you think about it, when winds blow on the surface of the ocean, they push the water. So that's how surface ocean currents develop. The trade winds, for example, push the water along the surface of the Earth until they get to a continent. And then that water is deflected. It's deflected until it hits another band of winds, the westerlies, and then it comes back across and then hits land again, turns down, and you get these circular currents called gyres. Gyres are circular ocean surface currents that develop because of the wind and because of continental blocking. In the northern hemisphere, gyres move in a clockwise direction. In the southern hemisphere, they move in a counterclockwise direction. So for oceans, you've got your surface ocean currents. You also have your deep ocean currents. These are the density-driven currents. This is thermohaline circulation. And what happens is cold, salty water at the poles, it's cold, salty water at the poles, it sinks and travels along the bottom of the ocean, and other water rushes to replace it. So you have warmer water coming from the tropics going to the poles, and it's transferring heat around the Earth. So that density-driven circulation is very important, and it's because of salt and temperature changes to the water. Next, with the ocean, you had tides. So tides are caused by the gravitational attraction between the moon and the Earth. And basically you get water bulging. So water kind of bulges, and we circulate through those bulges. And when we are in the middle of a big bulge, we're at high tide. And when we're on the opposite of a bulge, we're at low tide. So we circulate all the way through that every day, high tide, low tide, high tide, low tide. And so take a look at that, recognize what spring and neap tides are and how often we have those. And then waves. So what are waves? Waves just happen because wind blows on the ocean, and when it blows on the ocean, you get waves developing and the water moves in a circular pattern. When the waves intersect the shoreline, they pick up sand and throw it up on the shore, and then the wave goes back out, but not in a straight line. It goes sideways, and so it ends up carrying sand along the beach. That's longshore current or longshore drift. And so sand is constantly in motion at the beach because of the movement of those waves. So what people do, and this was one of the things that you dealt with in your discussion board, is sometimes they try to put structures there to stop that motion. So they can put things like groins or jetties there. So if the longshore current was coming down in this direction and somebody put a groin, for example, right here, and this is up current, so it's coming down. When it hits the groin, the velocity is going to drop. It's going to drop sand right there. And so you would build up sand, or sand would accumulate on the up current side. The down current side would then be starved of sand, and so you would get erosion. So take a look at that. Take a look at your beach replenishment or renourishment. Recognize how that works. Managed retreat. Take a look at that. Make sure you know what that is. So those are some of the main things that I want you guys to look at. And then finally, changes over time to our atmosphere. So we have recorded, and you guys saw this in mastering, an increase in the concentration of some of our greenhouse gases, like carbon dioxide. We can trace that to the burning of fossil fuels. And so we can see that with the increase in carbon dioxide, we should have an increase in temperature, and we'll take a look at that later. If we increase temperature, we should have higher sea levels, and we'll look at all of those things. You guys have seen already some of that. We've seen about a foot of sea level rise in the last century. And then any other effects that might have with our ocean. So if you are warming the ocean, you would have sea level rise. You could also, as you increase the amount of carbon dioxide, it could become more acidic. So you had a mastering question about that, about oceans becoming more acidic and affecting the corals. So main concepts: atmosphere, energy delivery, atmospheric circulation, ocean, surface circulation, deep circulation, tides, waves, beaches, changes in all of that over time. So if you have any questions, please feel free to email me. Still feel free to use your discussion board, and good luck. I hope you all do really well, and look for an update again in about a week. Okay, thanks.